We like to say that Cerro Chacnantor is the highest place on Earth to which you can drive a truck and have an observatory in a very dry location. There are various different topics that we're seeking to learn with CCAT. An important aspect of submillimeter astronomy is to be able to study dust and molecular material, cold material throughout the universe. So in the case of the nearer objects, the Milky Way, for example, what we really want to do is probe how molecular and dusty, cold material in the Milky Way moves from being distributed fairly widely down to a scale where a star and maybe a solar system-like object, a planetary system, can actually form. And we want to understand the process of that, going from something that's large to something that's small. Other telescopes are better designed to focus in on the small scale. We're like the wide-angle camera to ALMA, for example, zoom lens, which zooms in. We study the processes on larger scales. That's also true of trying to detect the first generation of galaxies that formed in the universe and started forming stars within them. We're not going to study them one at a time. We're going to study how the whole process worked. I think the outstanding quality of our telescope is the ability to be able to map the sky very rapidly and to observe at these very high frequencies for radio astronomy because we're located at 5,600 meters. We have a view of the submillimeter sky that can only be exceeded if you go to space. And by being very high up, we combine the property of being able to map the sky because we look over a large area of sky at once, to map the sky fast with the unique characteristics of being to observe the short submillimeter wavelengths because we're at an exceptional site.